The mean number of minutes for app engagement by a tablet user is 8.2 minutes. Suppose the standard deviation is 1 minute. We're asked, for samples of 60 tablet users, what are the mean and standard deviation for the distribution of sample means? In order to figure this out, we're going to use the central limit theorem. And to start us off, we need to know everything we possibly can know about the original variable. Now, reading this setup, it's pretty clear that the survey that was being described collected data, and the data was the number of minutes a tablet user was engaged with an app. So our original variable represents the number of minutes for app engagement. We're given the mean for this original variable, and we're given the standard deviation. Now we're ready to employ the central limit theorem to create a new variable, which represents the set of all of the samples, so the average number of minutes for app engagement. Notice that the original variable and the new variable are so similar. The only thing that's different is that the new variable is talking about averages, and the original variable wasn't. The original variable talked about individual tablet users. The new variable talks about samples and averages of samples. This new variable is using samples of size 60. We know that the mean for the new variable is going to be exactly the same as the mean from the original variable. The central limit theorem tells us. The standard deviation doesn't copy over so directly. There's a short formula which says this new variable has a standard deviation that's equal to the standard deviation from the original variable divided by the square root of our sample size. So, in order to find the standard deviation for our new variable, we'll take 1 divided by the square root of 60. 1 because that was the original variable standard deviation, and square root of 60 because that's the square root of our sample size. So the new variable has a standard deviation of about 0.13. So we have the first part finished, the mean and the standard deviation for our sample means. The next question is, what is the standard error of the mean? Great news, we've actually already done this, we just haven't interpreted it this way. The standard error is the standard deviation for our sample means. So the standard error of the mean is 0.13 minutes. Next, we're asked to find the 90th percentile for the sample mean time for app engagement for a tablet user. I like to draw pictures, so I'm going to draw a normal distribution for the data that we're considering. We have a mean at 8.2, and I'm looking for the 90th percentile, which means I want to know where to draw a vertical line so that 90% of the area is on the left of that vertical line. If I wanted to use a table to solve this problem, I would look for area in the table close to 0.9000. And unfortunately, that number is not on the table, but there's two numbers that are close. There's an area of 0.8997 and an area of 0.9015. 0.9 is a little bit closer to the 0.8997, so we're going to take the z-score from that area. The z-score for the area of 0.8997 is 1.28. Now the table only gives us z-scores, but we probably want to know the number of minutes that marks off that 90th percentile. So we need to convert that z-score into a variable value. We've done this before with an equation like x equals mu plus z times sigma, but we're not working with original variable values, so we have to amend this just a little bit. We're looking for an average, so we're going to use x bar is equal to mu sub x bar plus the z-score times sigma sub x bar. That just means we're going to use the mean and standard deviation from our new variable distribution. So we're going to calculate our x bar and find that it is 8.37. So the 90th percentile for sample means is at 8 minutes and 8.37 minutes. Sorry, that's not 8 minutes and 37 seconds. That's 8 and 37 hundredths of a minute. So our 90th percentile is found, and if we wanted to write out a statement for what that means, we could say 90% of the app users are engaged for less than 8.37 minutes. One last question, and that's to find the probability that the sample mean is between 8 minutes and 8.5 minutes. I'm going to reset my drawing so that I can shade the area represented by this question. First, I'll write it as a mathematical statement. So we're looking for the probability that our sample mean, x bar, is between the values 8 and 8.5. And we can add that to our drawing, a vertical line at 8, a vertical line at 8.5, and we'll shade between them. I can use a calculator with the built-in cumulative area functions to find this probability. All I need to do is tell the calculator what my distribution looks like, what the left boundary is and the right boundary, and I can find that there is about 0.9293 area between those two numbers, 8 and 8.5. So there's about a 93% chance that a sample with size 60 has an average between 8 and 8.5 minutes.